Good morning, my dear students in General Physics 2. We're now on week 19 under atomic. Our topic is atomic and nuclear phenomena. For our learning objectives, at the end of this presentation, you will be able to describe photoelectric effect and discuss the basic of nuclear reaction. So under the right circumstances, light can be used to push electrons, freeing them from the surface of a solid. So this process is called photoelectric effect or photoelectric emission or photoemission. So a material that can exhibit this phenomena is said to be photoemissive, and the ejected protons are called photoelectrons. But there is nothing that would distinguish them from other electrons because all electrons are identical to one another. So in terms of mass, charge, spin, and even magnetic moment. So in general, yung tawag ng mga ejected electrons are photoelectrons. So the photoelectric effect was first observed in 1887 by Heinrich Hertz. So siya yung nakafocus dun sa radio waves. During experiments with spark gap generator, ito yung earliest device that could be called radio. So in this experiment, sparks generated between two small metal spheres in a transmitter induced sparks that jump between two different metal spheres in a receiver. So compared to the later radio devices, the spark gap generator was notoriously difficult to work with. So the air gap would often have to be smaller than a millimeter for the receiver to reliably reproduce the spark of a transmitter. So Hertz found out that he could increase the sensitivity of his spark gap device by illuminating it with visible or ultraviolet light. So later studies by J.J. Thomson showed that this increased sensitivity was the result of light pushing on electrons. So a particle that he discovered in 1897, so 10 years after the first observation of photoelectric effect by Hertz. So it was Philip Lenard, an assistant of Hertz, who performed the earliest definitive studies of the photoelectric effect. Lenard used metal surfaces that were first cleaned and then held under vacuum so that the effect might be studied on metal alone and not be affected by any surface contaminants or oxidation. So the metal sample was housed in an evacuated glass tube with second metal plate mounted at the opposite end. The tube was then positioned or constrained in some manner so that light would only shine on the first metal plate. So the one made out of photoemissive material under investigation. So such tube is called photocell or an electric eye. Lenard connected his photocell to a circuit with variable power supply, voltmeter, microammeter. So we have the power supply, voltmeter, microammeter connected to the photocell. He then illuminated the photoemissive surface with light of different frequencies and intensities and observed, no? So knocking electrons free from the photoemissive plate would give it a slight positive charge. Since the second plate was connected to the first by wiring of the circuit, it would become positive, which would then attract the photoelectrons floating freely through the vacuum. So where they would land and return back to the plate from which they started. So keep in mind that this experiment does not create electrons out of light. It just uses energy in light to push electrons that are already there around the circuit. So this sets up a potential difference that tries to push the photoelectrons back into the photoemissive surface. So when the power supply is set to low voltage, it traps the least energetic electrons, reducing the electric current through the microammeter. So increasing the voltage drives increasingly more energetic electrons back until finally none of them are able to leave the metal surface and the microammeter reading is 0. The potential at which this occurs is called stopping potential. It is a measure of maximum kinetic energy of the electrons emitted as a result of photoelectric effect. Okay, so this is the photocell where dito yung incident light or incoming ray. And then ito yung surface, i-absorb yung energy from the light, and then there is emission of electrons. Okay, so photoelectrons. And then connected sa photocell yung variable power supply. So the word variable, pwede ma-vary yung potential, no? And then a device used to measure electric current in milliamperes. And also we have this voltmeter to indicate the value of potential, electric potential. So Lenard found out the following, that the intensity of the incident light had no effect on maximum kinetic energy of the photoelectrons. That the ejected from exposure to a very bright light had the same energy as those ejected from exposure to a very dim light of the same frequency. And more electrons were ejected by a bright source than a dim source. So later experiments by American physicist Robert Millikan in 1914, and he found out that light with frequencies below a certain cut-off value called threshold frequency would not eject photoelectrons from the metal surface no matter how bright the source was. So given that it is possible to move electrons with light, and given that the energy in a beam of light is related to its intensity, classical physics would predict that a more intense beam of light would eject electrons with greater energy than a less intense beam, no matter what the frequency. Okay, so we have this red light. So red light does not eject photoelectrons even if it is very bright. For green light, it does not eject photoelectrons even if it is very dim. Does eject photoelectrons even very dim, yung green light. While blue light, ito yung mga photoelectrons. No? Blue light ejects photoelectrons with more energy, with higher energy than green light, even if it is very dim. So, iba-iba, no? Kasi yung mga lights nag-differ sa frequency at saka sa wavelength. Okay. So the wave nature of light was confirmed when it was applied successfully to explain such optical phenomena as diffraction, interference, polarization, reflection, and refraction. If you can imagine light as waves in an electromagnetic ocean and be quite successful at it, then it would be much of a stretch for us to imagine electrons in a metal surface as something like tethered buoy floating in an electromagnetic harbor. So along come the waves which pull and tug at the buoys, yung mga electrons. So weak waves have no effect, but strong ones just might yank a buoy from their mooring and set it adrift. So if that was not enough, the photoelectrons seem to pop out of the surface too quickly. When light intensities are very low, the rate at which energy is delivered to the surface is downright sluggish. It should take a while for any one particular electron to capture enough of this diffuse energy to free itself. So the instant the light with an appropriate frequency of any intensity strikes photoemissive surface, at least one electron will always pop out immediately in a time less than 10 to negative 9 seconds. That short span of time, no? So continuing with the ocean analogy, imagine a harbor full of small boats. So yung boats are electrons. The sea is calm except for a tiny ripples on the surface. So this indicates low intensity, short wavelength light, and most of the boats in the harbor are unaffected by these waves. But one is ripped from the harbor and sent flying upward like a jet aircraft. So yung photoelectrons. And something just ain't right here. No mechanical waves behave like this, but light does. Okay, so photoelectric effect is the property of light, which can best be described by thinking light as a particle, not as a wave. So there are two factors affecting maximum kinetic energy of photoelectrons. The following are the frequency of the incident radiation and the material on the surface. So shown in the graph, we have electron energy increases with frequency. Electron energy. So this is energy on the Y, frequency on the x-axis. No? So electron energy increases with frequency, giving us this three curves. So in linear manner and above the threshold. So all three curves have the same slope. As you can see, magkapareho yung angle of inclination or the slope. So that is equivalent to Planck's constant, which shows that energy frequency relation is constant for all materials. So the genius that figured out what was going on here was no other than the world's most famous physicist, Albert Einstein. So in 1905, Einstein realized that light was behaving as if it was composed of tiny particles, initially called quanta, bundles of energy, and later called photons. And that the energy of each particle was proportional to the frequency of the electromagnetic radiation. Again, energy of each particle is proportional to the frequency of the electromagnetic radiation that it was a part of. And recall that Max Planck invented the notion of quantized electromagnetic radiation as a way to solve a technical problem with idealized sources of electromagnetic radiation called black bodies. Recall also that Planck did not believe that radiation was actually broken up into little bits, as his mathematical analysis showed. So we have this Einstein-Millikan equations to describe the photoelectric effect using the formula. So in contemporary notation. So relating kinetic energy maximum of the photoelectrons to the absorbed photons and the threshold frequency. Okay, so we have this relationship that maximum kinetic energy is equal to Planck's constant, where Planck's constant is equal to 6.63 times 10 to the power of 34 joules times second. And then this Planck's constant would be multiplied by the difference of the frequency of the absorbed photon, F, and the threshold frequency, F sub O. And in terms of energy and work function, we can also express kinetic energy in terms of energy of an absorbed photon, E, and then subtract from E the work function, phi, or phi. PHI. So the first term is the first term energy of the absorbed photons is equal to H times F, where H again is Planck's constant and F is the frequency. And I recall that frequency is equal to C over lambda from our last topic discussion. So pwede natin i-substitute dito yung C over lambda, where C is speed of light and lambda is wavelength. Then this also gives us the energy of the absorbed photons. So energy is equal to H, F is equal to H, C over lambda. And the second term, itong PHI, or the work function, is given as H times F sub O, or Planck's constant multiplied by threshold frequency. And in terms of threshold wavelength, this also equal to work function is equal to Hc over lambda sub O, or threshold wavelength. So the maximum kinetic energy of the photoelectrons with charge E can be determined from the stopping potential. And that stopping potential is equal to work over charge. So kung ma-recall natin yung topic ng electric potential, potential is equivalent to work over charge. We can equate work to energy. So kinetic energy maximum over charge, which is charge of electron. Okay, so from this relationship, from V sub O is equal to K max over electron, we can solve for K max. So K max therefore is equal to cross multiply E multiplied by V sub O. So when charge E is given in coulombs, when charge is expressed in coulombs, the unit of energy therefore is in joules. When charge is given in elementary charges, the energy will be calculated in terms of electron volts. So the unit of kinetic energy maximum would be joules in SI and non-SI electron volts. So we have this table, we have SI units and acceptable non-SI units. For Planck's constant, this is equivalent to 6.63 to negative 34 joules times second. In terms of electron volts, this is equal to 4.14 times 10 to negative 15 electron volt multiplied by unit of time second. For the product Hc, where H is again Planck's constant multiplied by the constant for the speed of light, equal to 3 times 10 to the power of 8 m per s. We have the unit joule.m, with value 1.99 times 10 to the negative 25. And its equivalent value in non-SI units is 1240 electron volt times nanometer. So lastly, the rate n over t at which photoelectrons with charge E are emitted from the photoemissive surface can be determined from the photoelectric current I. So recall again that I is equal to Q over T. And let's equate that to NE over T. So we can solve I over A from I NE over T. So that we have N over T. Divide the left and right side of the equation by E, giving us I over E equal to NT. Okay, for the application of photoelectric effect, first we have the electric eye. So this is light meter in movie, film, audio track. And another we have photoconductivity, so an increase in an electrical conductivity of a non-metal metallic solid when exposed to electromagnetic radiation. And then the increase in conductivity is due to the addition of free electrons liberated by collision with photons. Photoconductivity. And then next we have photovoltaic. So the ejected electron travels through the emitting material to enter a solid electrode in contact with the photoemitter instead of traveling through a vacuum to an anode. So leading to direct conversion of radiant energy to electrical energy sa mga solar panel. So yan ang example ng electric eye and solar panel. And also, photoelectric effect is used in photostatic copying. Okay, so next we have the second part. This is the nuclear phenomena. So we need to review first the atomic structure or structure of an atom. So this is, the atomic structure is analogous to a solar system. Wherein, sa solar system, the sun is the center. And revolving around the sun are the number of planets. So, pare-pareho dyan yung atomic structure, wherein the central part of the atom is called nucleus. That's comparable to the sun. And the nucleus composed of neutrons, where neutron is a neutral particle, and proton. So dalawa itong nasa nucleus, neutron at saka proton. So yun ang central part. And revolving around that central part are the number of electrons in different energy levels. Okay, so the mass of an atom is due to the number of protons and neutrons. So yung mass ng atom concentrated sa center. Na yung sa center, nandun yung protons at saka neutrons. And atom of different elements contain different number of protons. Atom of different elements contain different number of protons. May mga tanong doon last time. Kasi pareho lang ang subatomic particles ng atom, electron, neutron, and proton. So why is it that they have different characteristics or properties? Kasi they differ in number. They differ in number of electrons, number of neutrons, number of protons. That's why may different characteristics yung mga atoms. Now, ang electrons naman ang responsible sa volume ng atom. Kasi nag-move itong electron na to, creating a cloud. So, yun ang basihan sa pag-measure ng diameter or say volume ng atom. Okay, so we have this symbol X for element symbol. So, pwede ito ma-change. For example, ma-identify ninyo kung anong klaseng element ito. So wherein we are given A as mass number, where the mass number is the number of protons and number of neutrons. Well, atomic number is the number of protons. Number of protons. Now, if an atom is neutral, ano ibig sabihin ng neutral? Without charge, no? Neutral. So then, the number of positive charge, the protons, must be equal to the number of electrons. Okay. So when we talk about atomic number, that's number of protons. But then, if the atom is neutral, then automatically the atomic number therefore is equal to the number of electrons. Now, to compute for the number of protons, neutrons, mass number is given. So, i-deduct dyan yung number of protons or the atomic number. That's why we have A minus Z is to compute for the number of neutrons. So, neutrons, therefore, is equal to mass number less atomic number. Okay, so we have this two isotopes of uranium. We have uranium-235 and uranium-238 with an atomic number of 92. Okay, so in uranium-238, A is, alam natin that this is A and this is Z. No? So fill up pa natin yan, 238 ang A, Z is 92, number of protons is equal to the atomic number. So yan ang 92. The number of neutrons is the difference between 238 less 92. So that is equal to 146. So if you are asked pa, how many electrons? So since neutral, then yung sagot dito dapat 92. So next we have this uranium-235. So in uranium-235, our A is 235, Z is 92, number of protons is 92, number of neutrons is the difference, 235 less 92. And that would be 143. Okay, so an isotope therefore is an atom containing the same atomic number but different mass numbers. Okay, so any of two isotope, any of two or more forms of chemical element having the same number of protons, that's in our example 92, or the same atomic number, pareho din yun, but having different numbers of neutrons. They differ in neutrons, or they differ in mass number kasi nandoon sa mass number ang number of neutrons. Okay, so next is to define radioactivity. So this is the act of emitting radiation spontaneously. Then we have radioactive decay occurs in unstable atomic nuclei. So yung mga nasa periodic table, may mga nakalista dyan na mga unstable. So they need to emit particles para maging stable. So unlike other elements na stable na sila. No? So ang reason yan, that is one that does not have enough binding energy to hold the nucleus together due to excess of either protons or neutrons. So it comes in three main types, the alpha, beta, and gamma decays or particles. So what is an alpha decay? This is identical to a helium atom or helium nucleus being made up of 2 protons and 2 neutrons bound together. Okay. So in our simple presentation, itong nakapula ay proton at saka ito yung neutron ng helium atom. So yan ang nasa nucleus ng helium atom. Now, it contains 2 protons and 2 neutrons. Okay, so like in a chemical reaction, meron tayong chemical equation. So in nuclear reaction, we also have this nuclear equation. So in the left side, we have the unstable atom. Sa right side, more stable, but this is not stable, no? More stable than the left side. And then we have this alpha particle or alpha decay. So the rule is that sa more stable atom from the unstable, we have to subtract the mass number. We have to subtract 4 from the mass number and subtract 2 from the atomic number. That's to predict the more stable atom from unstable atom by emitting alpha particle. So we have this example. So yan ang rule. We have Rn, radon, 222 with atomic number 86. So what is Y? What is Y? What is A? What is Z? So emitting alpha particle. Okay, so alam natin yan. 4, 2 helium. Then let's subtract 4 from 222. That gives us 218. And let us subtract 2 from 86. That gives us 84. And identify what is 284 in the periodic table. That's polonium. More stable siya kaysa Rn. Okay. So next is the beta decay. Beta decay itself comes in 2 kinds, B or beta positive and beta negative, or beta plus and beta minus. So beta minus or beta negative emission occurs by transformation of one of the nucleus neutrons into a proton, an electron, and an antineutrino. So byproducts of fission from nuclear reactors often undergo beta negative decay as they are likely to have an excess of neutrons. While beta positive decays is a similar process but involves a proton changing into a neutron, a positron, and a neutrino. So we have the equation, basic equation ng beta decay. So on the left side again, we have a unstable atom, more stable, and the particle. This time we have beta particle. So this is beta particle, sign of electron with 0, -1. So the rule is walang ma-change, walang ma-subtract sa A or sa mass number, but then we need to add 1 at the atomic number. Okay, so example, we have TH. Ipahanap ano ang A, Z, and Y. So using that formula, walang pagbabago sa mass number. Still 2, 3, 4. And Z, just add 1. And then identify ninyo itong mass number and atomic number. Then this is equivalent to PA. So next is gamma decay. So what is gamma decay? After a nucleus undergoes alpha or beta decay, it is often left in an excited state with excess energy. Just as an electron can move to a lower energy state by emitting a photon somewhere in the UV to infrared range. So an atomic nucleus loses energy by emitting gamma ray. So what is gamma ray? So ano yung penetrating power ng gamma ray? This is the most penetrating of the 3. And will travel through several cm of PB. Kahit na si PB is used sa mga shield ng radiation, pero makapenetrate pa rin itong gamma ray. Okay, so yung beta particles will be absorbed by a few mm of aluminum. Few millimeters of aluminum. And alpha particles will be stopped in their tracks, be a few cm of air or a sheet of paper. Although this type of radiation does the most damage to materials it hits. So the equation for gamma ray, we have XAZ equal to XAZ and gamma ray 0, 0. So take note that there is no change in mass number or even the atomic number upon emission of this gamma ray. So we have this table, a reaction of alpha decay, beta decay, negative positron emission. This is beta decay, gamma decay. So in alpha or alpha decay, it loses helium nucleus. And yung mass number, mag-less tayo ng 4. Atomic number, mag-less tayo ng 2. While sa B+, this is loose electron from nucleus, no change, +1. Loose positron, yung B-, no change, -1. Emit high energy gamma ray. So yung sa gamma decay would emit high energy gamma ray. And there is no change in mass number, no change in atomic number. So next, we have to differentiate nuclear fission from nuclear fusion. So in fission, this is when a nucleus splits. So a heavy nucleus would split, no? So this is what happens in the nuclear power plants. Neutrons emitted during fission reaction can cause other fission reactions. This is called chain reaction. So in a nuclear reactor, the chain reaction is controlled by a controlled rad. Okay, next, what is fission reactor reaction? Fission nuclear reaction. Okay, so this is when two or more elements fuse or combine to form one heavier element. So the energy released by the sun and all stars is due to fission reaction in the core. This process release more energy than fission. But then, fusion reactions are hard to contain because the reactants are plasma. And at very high temperatures, therefore no solid material can contain a plasma. So sa mga nuclear reactors, usually yung fission ang ginagamit. That's splitting of a large or heavy nuclei to form light nuclei. Okay, we have this Venn diagram between fission and fusion. Fission, there is splitting of nucleus, while sa fusion, fusion or combination of light nuclei. So the end product ng fission is lighter than reactants. End product ng fusion is heavier than reactants. So in fission, reaction can be harnessed, while sa fusion cannot contain reaction because there's lots of energy is released. And common sa dalawa, energy is released and this a nuclear change. There is change in nucleus. So next is the half-life. So what is this half-life? No? Half-life of a radioactive isotope is a time after which, on average, half of the original material will have decayed. So after two half-lives, half of that will have decayed again, and a quarter of that original material will remain, and so on. Half-life, no? So the half-life of uranium-238 is around 4 billion years. So roughly the same as the current age of the Earth. While yung iodine-131 is 8 days. Cesium-137 has a half-life of 30 years. And because of this, and because it decays via the more hazardous beta process, is thought to be the greatest health risk if leaked into the environment. So the amount of radiation absorbed by non-bio matter or non-biological matter is measured in grays or GY. So this is a unit equivalent to a joules of energy per kilogram of mass. But for biological tissues, a dose equivalent is measured in sieverts or SV, depending on the type of radiation involved and how much damage that radiation does to a particular cells affected. Okay, a dental X-ray will give you a dose of under 1 millisievert. And a full body CT scan is approximately 10 MSV. So what are the effects of radiation on human health? There are two main health effects caused by radiation, which act over a short and long, also at shorter and greater distances. Okay. So radiation causes health problems by killing healthy cells in the body, and the amount of type of damage then depends. So depende yan kasi kung ang exposed sa radiation yung mga cancer cells, then may advantage yan. But then may mga matamaan kasi na mga healthy na mga cells. Okay, so the amount of type of damage then depends on the dose of radiation received and the time over which the dose is spread out. Symptoms of radiation poisoning: nausea, damaged organs, including bone marrow and the lymph nodes. So up to 3 SV, these same effects are more serious with likelihood of acquiring infections due to a reduced number of white blood cells in the body with treatment. So with treatment, survival is probable but not guaranteed. So yung mga may sakit na will undergo radiation, mababa yung mga immune system. That is why prone sila sa infection. Next, larger doses will, in addition to those symptoms above, cause hemorrhaging, sterility, and skin to peel off. If untreated, more than 3.5 SV will be fatal, and death is expected even with treatment for doses more than or greater than 6 SV. So receiving a high dose in a short time, take note, high dose in a short time causes more acute damage, as greater doses kill more cells while the body can have had time to repair some damage with more time having elapsed between doses. However, radioactive material that is spread to a wider area causes longer-term health effects via prolonged exposure, particularly if they enter the food chain or inhaled or ingested directly. So taking radioactive materials into the body also presents the greatest danger from atoms that undergo alpha, as alpha particles are not very penetrative as gamma ray and are easily absorbed. Madali absorb ang alpha particles now by a few cm of air. It was alpha-emitting polonium-210 that was used to murder Alexander Litvinenko in 2006. Ang namatayan niya is lethal polonium poisoning. This is radiation poisoning. So radioactive isotopes of iodine, which undergo beta decay, can build up in the thyroid gland and can cause thyroid cancer. Attempts to prevent this involve distributing pills that include non-radioactive iodine 127 and which flood the thyroid, preventing uptake of radioactive iodine. For one-off doses, such as those from medical scans, the risk of developing cancer is estimated at around 1 in 20,000 per milli-SV received. Okay, so however, there is disagreement over whether very small doses comparable to the level of background radiation actually contribute to health effects. Okay, for our lesson summary. Under the right circumstances, light can be used to push electrons, freeing them from the surface of a solid. So kung meron tayong incident, light, i-absorb yan ng surface and would emit electrons. Okay, so this process is called photoelectric effect or photoelectric emission or photoemission. And a material that can exhibit this phenomena is called photoemissive, and the ejected electrons are photoelectrons. So radioactivity is defined as the act of emitting radiation spontaneously. Radioactive decay occurs in unstable atomic nuclei, that is, ones that don't have enough binding energy to hold the nucleus together due to an excess of either protons or neutrons. So it comes in three main types, the alpha, beta, and gamma. So what is alpha particle? This is identical to helium atom, being made up of 2 protons and 2 neutrons bound together. While beta, decay or beta particle occurs when an unstable nucleus emits a beta particle and energy. So either an electron or a positron. Gamma decay is one type of radioactive decay that a nucleus can undergo. What separates this type of decay process from alpha or beta decay is that no particles are ejected from the nucleus when it undergoes this type of decay. So meaning walang pagbabago sa atomic mass at saka atomic number. Okay, for fission and fusion, sa fission, there is splitting of nucleus, while fusion, there is combination of nuclei. Yung end product ng fission, lighter than reactants, while sa fusion, heavier than reactants. In fission, reaction can be harnessed. Fusion cannot contain reaction. There's lots of energy release. But then, yung dalawa, there is energy release. And mag-change yung nucleus. There is nuclear change. Lesson for today.